welcome audience. This is our next session will now be beginning. Thank you all for attending. Our session today in this panel is called Towards Net Zero, Delivering the Future Today, which is an exciting and possibly wide variety of things we'll be speaking at. So I will leave it to the moderator, Keith Whitchurch, to take it away and introduce your panel.
Thanks, Justin, and welcome everyone, and welcome to our audience. So, it's an exciting and fairly full program for this forum, and a pleasure to be here. So we have 3 of our 4 planned panelists with us who are boldly going forth to develop projects in a way that has never been done before. And it's my 41st year in the mining industry, and I have to say it's really been a more exciting time where the industry is moving at a pace that I've never seen, and it's a positive direction that it's moving in. So what I'd like to do is just hand off to each of our panelists to do an introduction. Yourself first. If we just do that, who you are, how you got here, and then we can hand over to each to do a short presentation on your particular project. So Øystein, over to you first.
So
yes.
I'm Øystein Rusfeldt. I'm Norwegian. We do have a copper project in Norway, which is coming pretty close to a decision of construction within half a year or so. I've been working with this project for 13 years, so that's the time it takes to go through permitting in a modern country. Before that, I've been working with a number of different smelters and mining organizations in Norway, mainly working for multinational companies. So it's a global world. Norway is a small country, but we are very much part of a global world with oil, gas, metals, mines, etc. And I think in particular, being from Norway with the huge amount of oil and gas we are producing, which again creates CO2 emissions, we have a particular obligation to do projects that can lead the way. So even if our copper production of some 25,000 tons per year when we are in operation is not going to change the world with regard to access to enough copper for the turn from a fossil fueled time into the renewables. But what we can do is to add these tons into the world market with the lowest CO2 emissions that has been ever done from a mine. So we are targeting to start the production with 0 CO2 emissions from both the underground operation and also from the processing part. Obviously, it's not going to be perfectly CO2. We still have blasting and we still have welding and these kind of things, but it will be as close as it is technically possible to 0 CO2 emissions. And it's also an interesting perspective to lead the way in such important area. And that is that the power that will be used the electrical power that will be used to power the operation is purely fossil free, because we do have a huge overproduction of electricity in northern Norway, where we are situated, which means that we will be powered by hydro and wind farms exclusively. And I think that when you are going to produce copper and you're going to participate in the future need for these metals to take this green shift, then your metal cannot be part of the problem, which is certainly the case today for most mines, being also a position of letting out CO2 emissions. So the new mines will have to be a part of the solution, and to become part of the solution, you need to severely cut back your own emissions, but you also need to source energy that, again, in itself is free of carbon. And I think this is the main challenge. And as I said, we're not going to produce to be the largest copper mine, but we would like to be the first copper mine that is practically zero. And then due to being an example, we think that we might then have a greater impact than our own tons only. And we have been working quite hard to get enthusiasm for this to be out there first. We have teamed up with the Swedish Epiroc so that their fleet will be all yellow during the underground operation. And we are also teaming up with others these days in order to prepare a partnership where we, together with key partners, will make this happen within a very short time frame, just a few years until we will be zero emissions. So this is what we can do, and this, I think, is what we are obliged to do. And as miners, there's no real choice. Diesel is the past, and we will have to leave that past and move into a sustainable direction. So thanks for those few words.
Thank you, Øystein. So Andrew, do you want to just carry on?
Yeah, happy to do so. Thank you very much, Keith. My name is Andrew Osterloh. I'm with FPX Nickel. We're a Vancouver-based junior miner developing a very large nickel asset in central British Columbia. Little brief bit about myself. Metallurgist by background, spent the first third of my career in either operations or project development on the owner's side. Spent the middle portion of my career in development of large-scale mining projects throughout the Americas, and joined FPX Nickel in the middle part of last year as VP projects, but ostensibly have responsibility for operations and exploration and all project development activities there. So when we get to the slides on the specific project there, I'll talk some about the interesting nuances of our project that give us a very credible opportunity to be, not just a net zero producer of a significant portion of nickel units, but potentially a net negative, and how some of those implications dictate how we develop the project along the way there. So thanks for having me.
Thanks, Andrew, and I'm loving this concept that net zero isn't enough. Let's don't aspire to mediocrity. But Todd, last but not least.
Yeah, it's super, and really happy to join everybody today and just say a little bit about what we're doing. I'm with Talon Metals. We are the owner and operator of the Tamarack Nickel project in central Minnesota, about 45 minutes west of Duluth. That is one of the only high-grade sulphide deposits discovered in the last decade. So Tamarack is on par with high-grade nickel deposit discovered in the state of Michigan, the Eagle mine, which is the only operating nickel mine in the United States right now, and then Nova Bollinger in Australia. And we struck a offtake agreement with Tesla to provide 75,000 metric tons of nickel in concentrate in 2026. And we will start the permitting process in the beginning of next year in the state of Minnesota. We're very excited about some of our plans to produce nickel at a very low CO2 footprint in comparison to nickel, say, from Indonesia or other places around the world. We plan to do that, obviously, by decarbonizing mine operations. That's a great thing about being in a new mine that you get to plan around a decarbonized operation. And then, as Andrew mentioned, we too have the right kind of rocks that actually could be very significant carbon sink. And so we are doing quite a bit of work on carbon mineralization of our tailings, of cementatious backfill. And then we have one part of our deposit that actually could be in situ a very large carbon mineralization project. And we're working with our JV partner, Rio Tinto, on that, and they're leading the science that has to happen around that area. We were recently awarded some funding from the US government, from the US ARPA-E at DOE, to, again, conduct those scientific experiments to look at what the size of the prize is in terms of carbon mineralization. But we think that just within our tailings and our paste backfill that we'll be able to get close to zero or actually above zero in terms of what we're able to offset in our operations. So very excited.
That's great. And I see we do tend to turn ourselves in knots with, you know, net negative is a positive. We're going to have to figure out the term.
I'm going to have more offsets than
communicate clearly.
Than I need.
Yeah, net negative is a positive. So that's one we can all work on. So now I know Andrew's got some slides on his project. Todd and Oyston, do you? No, that's fine. So Andrew, do you want to just run through yours now?
Yeah, so I won't dwell on all these things that are related to the corporate side of things, but some real strong advantages. And as Oyston mentioned there, these are things that are increasingly becoming important in the permittability of these large-scale projects. But for us, a lot of strengths going for us to be able to produce a truly sustainable type of mine. While it is a large open pit mine and will undeniably have a large impact on the landscape, there's a lot of considerations to it that really make it a big step forward there. It starts with the carbon intensity there. We're going to be on the low side of carbon intensity in the nickel industry, and a very credible path to take that carbon intensity close to zero, even negative, through lower emissions mining fleets, as well as the sequestration of tailings, which Todd mentioned. They have a similar type of mineralogy at Talon. A virtual lack of sulfur in our rock, which creates our unique type of mineralization, basically creates a non-acid generating scenario there, which obviously has great footprints implications in terms of site layout, as well as the geochemistry, very stable rock to really reduce the demand on water treatment and whatnot. I think nickel, it's not just the stainless steel industry that's growing regularly. To support the electrification, the requirements for nickel in the world are quite staggering. Right now the current annual market is around 2.5 million tons. In 2050, with current projections, that needs to be about 9.2 million tons, with the vast majority of that coming from the EV space. So, a pretty dramatic role that nickel and these other battery metals play in the electrification of the world here. We're located in central British Columbia, right in the middle of a mining jurisdiction. And I think, again, something that's really unique about our deposit is a lack of sulfur at the time of placement, where that's, that alteration that creates typical nickel sulphide minerals. With us, with that lack of sulfur, we created this unique mineral, awarenite, that's virtually devoid of sulfur, which allows us to either directly access the stainless market or the EV battery market without any intermediate processing. So no smelting required if it needs to go into the stainless market, or no intermediate processing ahead of a fairly simple hydrometallurgical circuit to go into the EV battery space. So, what does that mean? Lower overall carbon intensity for the complete supply chain. Less time to market for nickel units in ground to nickel units going into batteries. Et cetera. Lots of good things come out of that. Where are we on the carbon intensity scale? Again, already quite low, as Todd mentioned. A lot of the ferronickels and the nickel pig irons coming out of countries like the Philippines or Indonesia tend to be quite high, and it's really back to that source of power and the carbon intensity associated with, much like Oyston mentioned there. Us being able to use entirely renewable energy in British Columbia in the form of hydroelectric power, we see a carbon intensity of around 2.4 tons of CO2 for every ton of nickel we produce. And then again, as Todd mentioned there, that unique mineralogy, brucite, or this magnesium mineral, has the ability to sequester carbon dioxide at roughly a 1-to-1 ratio, and we have about a 1% brucite ratio in our resource as a whole there. So, provided we can get the right access of CO2 to the tailings, there are a very significant opportunity for us to meaningfully sequester carbon dioxide as a carbonate mineral. And not all carbon credits or not all carbon sequestration is created equally. You can imagine things like carbon sequestration in the form of trees or whatnot. That's relatively a temporary form of carbon sequestration, where if you're actually mineralizing the CO2 into a new mineral, that's generally permanent on the geological timescale. So it's a very meaningful opportunity for us. Where does that see us on sort of a waterfall chart? Again, we're at about a 2.4 right now. The low-hanging fruit for us to get that number below 2 is just to electrify the drilling and the loading equipment in the pit. That PEA base case considered an entirely diesel fleet. Haulage is the biggest production of CO2 in our operation right now, at a little over 1.1. So if we look at these emerging opportunities in either hydric or electric powered haulage fleets, that takes us below 1. And then only 5% of our brucite needs to be reacted in order for us to reach net zero. And our modeling shows that even just passively, with doing very little, just creating a tailings facility with fairly typical exposure, we could see something double that. So something that would take us down to negative a half ton of CO2 per ton of nickel. So pretty exciting from a project development perspective. We're continuing to move forward this science here to support the permitting of the project.
Thanks, Andrew. That's fantastic. So we've got a project in Canada, a project in the USA, and one in Norway, and I'm sitting in Indonesia. So we do have the globe surrounded. And copper and nickel, which I think everyone agrees absolutely essential and in vast quantities. So all doing our little bit. What would you say to each of you in turn? What's stopping you breaking ground immediately? What's between you and breaking ground, the hardest thing? So Øystein first, 13 years.
Yeah. Permitting in our part of the world is really breathtaking, but I think it's actually a global phenomenon, and it's needed. But it means that currently the world today knows which mines, both in copper and nickel, will be possible within the next 15 years or so, due to this permitting. Which means that there will be challenges to feed the need, and hopefully the need can be fed from countries that actually are in need of these metals, not only from Asia or countries that are not that democratic. So not going into that, but I think that what we have seen, we tried to look into a full electrification already 8 years ago, realizing that that was too early. But since the permitting took such a long time, we actually are coming into a time slot where the equipment is ready, where we do have the renewable energy at very, very competitive prices in northern Norway, luckily. And we also see that the markets are ready. We do have a national electrification fund, so to speak, in Norway called Enova, which gives out grants to those who are moving things in the front. So if you're a front runner, you may have up to 50% of your additional electrification cost covered by the state. If you're number 2, you're not getting that attention, and then it goes on. So we are looking forward to have some help from the state. It will still be very expensive. The equipment is certainly expensive, but the mine itself will be different. It is if you make an electric mine from the very start, you will do things different. You will have less ventilation. So, and that goes from the start. So your tunnels can be slightly smaller because of the fan equipment, and and you need a lot of electric energy into your mine, and that infrastructure needs to be there from the very start. If you're an old mine, you will have a huge problem to start electrification. One of the things we are looking into now is that typically when you have an underground mine, you have a classical sub-level open stoping, your drill drifts are flat, and that's normal. So you would expect your electric mine to do the same, but we are looking into inclined drill drifts so that the transport of ore, which is rather heavy, generates energy on its way downwards and then goes up again to pick up the next load with an empty machine, and thereby you're doing things that you're not doing in a diesel mine, and the electric mine is becoming different. And then during these years we got a look at Borden Lake, which was a very early front runner, a good example. We had contact with those guys, and they helped us a lot. I think what we're seeing now with Andrew and Todd and with these friends, that we have kind of rather exciting and friendly competition to become first zero or net zero or close to zero mine operation, which I think is a fantastic thing to be in part of such a competition. I think this will create a lot of enthusiasm for people being interested or potentially attracted to the industry. And we're seeing that we're getting quite a few young applicants interested to work with us from the very beginning, not because we are in a big city of Oslo, we are far from that, but they would like to participate in something that is brand new and which is part of the future and which they can relate to.
If I could jump in there, yeah, I would echo everything Øystein just said there, and maybe one sort of knock-on effect of that. And our project development critical path firmly runs through permitting, whether it's the project definition to define a footprint, the baseline studies, the actual EA process, or formal permitting itself. In Canada, that process runs typically in the region of about 6 to 7 years between very preliminary project definition and being able to have a permit in hand. And that's a very significant burden on the development company. And the knock-on effect of that is, these projects, we have to be able to access capital, be able to develop them effectively, and to be able to keep the markets excited through those sort of, grinding years of project development and permitting. Permitting, there's not a lot of sort of sizzle that you can sell to the market on, to be able to raise capital and whatnot. So as a junior miner trying to push forward a project through that long, arduous path, that's certainly a challenge there.
Todd, being 45 minutes from a capital city, that's interested to hear what you have to say on this.
Not the capital city, Duluth is,
still
in St. Paul. But, but I think, I agree with all the other comments. I just think that, I think it's very clear we're at an extraordinary time in, developing projects like all of us are talking about, is that there is now a realization that we need the raw material in order to have the energy transition that is necessary to deal with climate change. And you have more and more elected officials, President Biden at the forefront, talking about how we have to have responsible mining and recycling, and the whole supply chain has to be addressed. And I think that really is helpful to actually get people to realize that, yes, we are going to have to disturb the earth, but it's a totally different context than fossil fuel extraction, when the nickel and the copper that each of us want to extract from the earth is infinitely recyclable. So what we actually are producing can be tracked and traced into the battery supply chain, into other supply chains for copper, and that it can be very sustainable in the sense that these things are recyclable. I think that's a totally different shift in terms of how we actually talk about permitting and social license that I think the industry's got to do a lot more on, is reminding people that we are disturbing the earth. We have to be responsible about that disturbance of the earth. We have to have good plans for closure and financial assurance. But what we are extracting, that product is recyclable. I think that all of these things, though, whether you think about the decarbonization of the mine for the sake of the end user, the values customer that wants to know that the materials that in the car that they're buying have been responsibly produced, or whether you're thinking about the communities where we operate, all of these steps, decarbonizing mine operations, being attractive to young people who want to be a part of the climate story, and new industries like carbon mineralization could be, or whether it's about, just other aspects of responsible operation, all of these things go back to making sure that we can make the case that we deserve to operate, that we deserve to, and that we have a proper place in society. And I think that's what a lot of each of these tactics or these ideas or innovations are really directed back towards, which is, will society lower the amount of time that permitting takes for a mine? Because we have a crisis. We don't want to cut corners on environmental review, but can we make sure that an air permit and a water permit are being, pushed through the system at the same time? So you have sort of contiguous permitting versus seriatim, doing things in a step. There are ways that you can make it more efficient.
That's great. And there's a bit to unpack there, and a question's popped up, which is around, if permitting's taking so long, what happens if a new technology crops up? You're halfway through the thing and someone has a eureka moment and says, I've got it. We've had panels talking about microorganisms, and there's something that's a game changer. Does it reset the clock? And is that a barrier to saying, everything we've said so far, we're going to change it for the better? Say, Øystein?
Yeah, our permitting took 10 years and 21 days and ended up close to Christmas one of these years. So it is a dramatic burden, obviously, both with regard to financing and keeping motivation. So I think, yes, in order to be able to feed society with these critical metals from projects that are actually relatively much more sustainable, these projects should get a fast track or a positive, on the airport with the security, there's a possibility to go fast track if you have the right stamp on you. So that is one of the things that could help out, really. So
both Todd and Andrew's project have this element of an R&D stream going on the net negative, positive emissions. Wonder how that would...
Sorry.
So I was just wondering, Todd and Andrew, how would that impact on your permitting? Or is that, if you come up and say, look, you're going to do something different, do you start again?
Yeah, I think it's important to recognize that no permitting process is equal in different jurisdictions. They all have their own nuances. The Canadian permit process, which I could probably speak, most eloquently about, there's certain considerations within that process that are very onerous, and you have to be able to meet the same commitments on day one and when your permit's actually issued. And then there's other things that are a little less impactful. So in Canada, things like water footprint, emissions, those are the things that are really significant. And then when I say footprint, I mean the project's footprint in terms of the impact on baseline studies. Where things within the process plant or some of the things within the mine, as long as it's within a sort of contextual reason, you know, there is some flexibility to be able to evolve and adapt as things progress. It's not an easy thing to do, but there is some opportunities to create, you know, to embed new value into the project. That same flexibility doesn't exist in other places. I've, you know, spent a fair number of years working on Chilean projects, for example, and the permitting process there is incredibly defined. And, you know, the idea of moving, you know, a physical facility, you know, meters between the start and the end of permitting is a big deal there. So the, you know, it's a bit horses for courses. You know, I think we have a responsibility as developers and operators to continually look for the best technologies to you know, to apply to our projects. Much like we have the responsibility to be, you know, stewards of capital, whether or not we're dealing with high or low grade projects. You know, that same onus of responsibility still falls on us to extract the maximum, you know, value from each of these sites, get the maximum, you know, value within environmental reason there.
So,
yeah, I would just add to that I do think that you do run a risk if you're bringing something new and innovative to the table, that regulators or the community says, oh, that's new and maybe it's scary. I think the thing that Andrew and I are talking about is my gut feeling is that it's incredibly compelling because it's ultimately about healing the earth. Because what we didn't talk about is, where's your source of carbon? Yes, the rocks we have can actually form a carbon sink by being able to mineralize the carbon through the natural reaction between carbon dioxide and the rocks. But, you know, if we're pulling that in from direct air capture, where you're removing carbon from the atmosphere, then we're part of doing something where you're really at the forefront of the carbon removal fight in climate change. And that's really at the cutting edge. And this goes to some of the comments from in the chat. And I'm really excited about that. Again, there's a lot more science that have to be done, but I think it is a fair point to say, you know, if you're working on your mine and your mine plan, and, you know, that's sort of a known quantity, and you add something new in, there's a risk that people say, oh, well, slow down, let's talk about it. And I think we have to be brave about that and recognize that because we're doing something new, people are going to want to know about it, but that doesn't mean that it automatically tacks on a big amount of extra work. At least I hope not.
It's good. But probably, you know, it's a neat segue into, there's something you said, Todd, about communities where you operate. And I picked up in, you know, reading a bit of background about the proactive engagement with the community and an open door policy. As there's a couple of things on that, you know, how important and how effective is that proving to be with the permitting process? And is there a whole new set of skills required of mining people today, you know, that, you know, enables that to happen effectively?
Yeah, I mean, I think that we do have an open door policy. We do quarterly community meetings. We're sharing information with sovereign tribal governments. And I think in this day and age, I think that's just table stakes. I mean, that's just the minimum expectation. Because I think that we have to be used to society questioning our value proposition. I think we all have conviction that we add a lot to society through job creation, through the products we make, and the things that we make possible. But we just have to be, you know, the mining industry is sort of sometimes balked at that question, like, why do we need you? Or thought it was just axiomatic. And I think we have to actually be patient and actually get out there and explain it and talk to people and answer questions. And we're in a really interesting phase. We're shaping our final mine plan to go into environmental review and permitting. So if you're a good listener and you understand what people are worried about, you have an opportunity and you're shaping your mine plan to address some of those concerns, hopefully most of those concerns.
Yeah, I think that's an entirely fair comment. And, you know, in Canada, the permitting process is quite well defined and somewhat easy to benchmark to. But just as important right now is social consent for a project. And there will be no mine built in Canada that doesn't have, you know, collaboration, consultation, and consent from local stakeholders. It's just the way it is. And that's not just the mine itself. It starts from day one when you're doing exploration activities and whatnot. So and that process is much less defined and much less much less natural for us engineers and us project development people to go through. So, you know, I started out my career thinking that the technical side of things were the crux of all these projects. At the end of the day, those are what makes a project successful. But in order to get a project built, it's the layers and layers of things around it that really are becoming increasingly important. And, you know, permitting, consultation, all these categories here, you know, you can't overstate the importance of them these days.
And Øystein, the view from Europe?
Yes, it's I think this is pretty much the same all over, at least the part of the world which we are arriving from. So in our case, I've been involved in hundreds of meetings over these years, from large, very exciting town hall meetings where a big chunk of the local community actually arrived to the first meetings. Quite fascinating. And then a lot of these meetings actually one-to-one in people's home over coffee, when you understand that there's a specific need, and you just have to go on, and you can never stop or say that we have said enough. It's the social license is no longer vital; it's existential. So you can just pack and go home if you're not 100% with that. And also just mentioning, I think I didn't answer your previous question with regard to how the authorities are able to catch up if you started 10 years ago. But in Norway, that works pretty well. We are able to talk to regulators and make them understand that we're not going to be diesel anyway. So forget about the diesel amounts that we had early on in the permits, and so that is possible to do.
That's brilliant. So on that communication, Steve, I suppose there's a leading into a little bit of a Brock ad here that there is a significant component of the technical courses where the opportunity to study communications is there, and I don't think that was around when any of us went through. You know, it was very much a technical education, technically focused, and if people didn't understand us, that was their problem. So I'm sort of looking for where, so young students who might be studying something like communications, do you see a place for them in the mining industry, you know, or need? Yeah.
If I may, we actually a good year ago had a young lady arriving from her studies, finished degree, and joining us for a trainee period, and doing fantastic work with the communications, but at the same time being really technically on a very high level technically, but also being able to communicate it in ways that we never were trained for. So by having this young person coming on board, we actually made huge steps forward, which I think we, sorry to say, older guys would have struggled somewhat with. So that is something I can truly recommend. And also another aspect we did in order to gain people's interest into this ESIA studies, which might be quite heavy and lots of documents and papers. So what we did with the most critical studies is that we practically handed them out to the affected parties to come back to us and name which kind of experts wherever in Norway do they trust and find to be the right organization or individuals that could be the leader of the ESIA study. And we did that for all of the critical ones, giving them away. We just got a bill in the end, but the whole ESIA study was moved forward by the affected parties. That was a major success for the building the social license. It was a little bit, it has never been done before in Norway, so we were a little bit nervous. But I can also recommend such a way to handle the studies and just give it away to people, and then have some groups coming together to discuss, and you're just a secretary and you pay the bill, but you don't really go in there and start changing their views.
Thanks, Øystein. And Todd or Andrew?
Yeah, I think I'll sort of maybe touch again or expand a little bit on a comment I made in my last statement there. The days of project teams being groups of engineers in a dark room are long behind us. And I say that with a bit of solace as an engineer, but we're forced to wear a lot of different hats, and some of those don't necessarily come naturally to people with a technical background. There will always be a place for technically competent people. There will always be a need for technically savvy people. But what's emerging is a real strong, requirement and a source of value based on people with ESG backgrounds, communications. There's all sorts of different functions that were, technically there before, but they're now really predominant and equally important parts of a project, much like the actual technical aspects of it these days.
Yeah, and I could just add that, coming from somebody who's the chief external affairs officer for a company, and my background is in communications, I think that it will be an incredibly important part of the senior leadership team of a lot of mining and materials and recycling teams, companies, to have good communications people with experience, good community engagement people throughout the organization, at projects, in the C-suite, and on boards. And that is actually a kind of an appealing career trajectory for students that are starting out. It used to be that sort of communications or government relations or tribal relations people were off to the side and got consulted at the end of the project and said, oh, go out and make this work. And I think what you're seeing is that it's becoming incredibly strategic and part and parcel of how projects get done. And I think that means that it has a career trajectory that's quite appealing. And it's great to work with technical people that also know how they're actually going to get done. So I find that really satisfying.
So Justin's put a link in the chat there, which is talking about the Brock University and the science and communications, joining those together. So that's, I think Brock is leading the pack on that, to recognize that is a critical skill of a modern technical person, being able to, yeah.
And it is, I work with the team at Brock that actually has put this together. So it's the Bachelor of Arts and Science. So it's a BASc in Earth and Planetary Science Communication. So it's this actual new unique degree that combines communication skills with a strong background in science. And the range of projects we're seeing that are possible are, like doing entire Instagram things about volcanoes, or doing a project where, you go to a political nature and give talks and learning how to communicate science on a major communication platform. So they're really proud of it.
Yeah. So exciting times in innovation. We're catching up on some of the questions here. So there's a comment in there about the lack of innovation in mining for decades, but you know, as we're all talking about, we're entering a period of rapid innovation and a real drive to adopt, because what's been done in the past isn't going to be acceptable in the future. But regulators appear to be lagging. While the political people are saying all the right things, the regulators, the bureaucrats appear to be lagging. And you know, not necessarily their own fault. You know, they're not allowed to use initiative. You know, they've got to follow the rules, or someone's going to challenge it in court somewhere. Any real thoughts on how that can be changed, you know, modernized? Or?
Yes, I think we'll just have to accept that the authorities, the bureaucracy is what it is. It's not going to be less or faster, or sorry to say, which means that we that are in the businesses will just have to be even more focused, more forward-leaning, and make things happen, but not alone. So it will have to happen together with, like we do now with Epiroc as a partner supplier, not just a supplier, but it's a part of the project. And there will be other partners, and we're looking into which smelter to become partner, to have our valuable low carbon copper concentrate, or zero carbon copper concentrate. We've been talking to obviously the two big in Northern Europe, the German smelter in Hamburg and the Swedish Boliden. And those who have followed have possibly seen that Sweden just launched low carbon copper metal as the first certified low carbon copper metal in the world ever. And they didn't get any pay for it so far, but just a few weeks ago, they got the main contract to deliver the copper to the world's largest offshore windmill farm, because the windmill farm is, of course, the future for renewables, and the copper cannot be dirty. So Boliden got the big prize, and yes, it's not a big secret that we like Boliden, and so this is the way to build maybe not with the help from bureaucracy, but to build this value change which is needed for the future. And yes, we will be helped by the Enova fund in Norway, but I think we will still see permitting processes take years also in the future, unfortunately.
So we're coming to our last few minutes. So I'd probably like, you know, each of you to just sum up. You know, what is the message you'd like to get across to the young people of the world about the mining industry and your projects?
I'm happy to go first. I'm just, it's really a sense of excitement that you're beginning your careers at a time when there's a massive amount of focus in this area, there's innovation, and there's tremendous new resources from governments in particular, Canada, the US, EU, very focused on providing new resources to build up these supply chains in the electric vehicle supply chain and other renewable energy supply chains. So it's an exciting time to be coming to considering a career in this area, whether it's in technical disciplines or whether it's in something like communications. It's I'm really upbeat about it. I tell people that there's probably never been a better time to be developing a battery minerals project in the United States. That's for sure.
I would echo, this is the most exciting period of the mining industry since I entered it 25 years ago. And I think, you know, I would just sort of maybe qualify the comment in the chat a little bit. I think mining has come a long way in the last few decades, but what we haven't really necessarily done is demonstrate that or share that improvement with the world. And part of it because, you know, operators don't tend to like to be in the news. You know, you don't want to tend to be talking about less impact. You don't want to be talking about impact at all. But I think as us, you know, us as industry participants at a pivotal point in time, it's up to us to demonstrate and to share with the world that these projects can be done responsibly. And these projects can be done with a very holistic vision. And, you know, we can work together, you know, not just with the company representatives, not just with the stakeholders, but, you know, the local stakeholders and really, you know, all share in that value proposition and make a collective decision together. And I also don't mean to be railing on permitting here as well, because I get it. Like if somebody wanted to come and build a mine in my backyard, I would want to be very certain I knew what was going to look like, what it was going to look like, and what it was going to look like after it was closed. So, you know, we all have to be part of that process there. And, you know, with all the opportunities out there, it's an exciting time for everybody to be entering their career here. So I look forward to all your inputs into this progression.
And Øystein?
Yeah, thank you again, Keith. So what we are doing, of course, there's a lot about technicals. It's about machinery and emissions, etc. But on top of that, and in order to solve everything, it's all about people. And as we have understood from this chat, a mix of skills between people, and it will be teams. People will be teaming. And I think that what we will see that it's for us, it's about having those enthusiastic young people coming on board. We are open and willing to employ young people, and even from Canada. We love Canada. I've been to Canada every year, meeting friends over there. So please feel free to have a trip over to Northern Norway and have a look.
That's brilliant. Well, thank you, everyone. We've pretty much nailed our time, which will keep Justin happy. And I have to say, I absolutely agree with you about how exciting this time is. And I wish I was 20 again and starting. It'd be great. So with that, I'd like to thank you all three and hand back to Justin.
Thank you, guys. So that concludes our panel. I do want to thank you, Keith, Øystein, Andrew, and Todd for that in-depth discussion. I definitely benefited from it, and I'm sure the audience did as well.